Welcome to the deep dive. Today we're tackling some source material that's, well, it's pretty specific and, frankly, extremely assertive.
Yeah, it really is.
We're diving into a system that claims to make existing standards, things like HEPA filters, even clean rooms, basically obsolete, at least when it comes to our health.
The analysis is called Beyond Cleanrooms, and the inventor behind this air six-free maze purification system, they're really not mincing words.
No kidding.
The source calls the inventor the master, and they state pretty bluntly that comparing this invention to a clean room is ignorance and blasphemy.
Wow.
Okay, so yeah, that's the level of confidence we need to unpack here. Our mission is to really understand their engineering argument, why they believe the systems protecting, multi-million-dollar microchips are actually failing your lungs.
Okay, so let's frame this up for you listening. We've got two very different ideas here. On one hand, traditional clean rooms. They're built for manufacturing, right?
Yeah.
Protecting silicon wafers.
Exactly, consistency for products.
Then there's this Air 6-free maze purification system, and they're positioning it totally differently as biological protection engineering for the human body.
It's a fundamental shift in focus, apparently, from protecting inert stuff to, well, protecting people, survival even.
So let's get into their main criticism. Why do they say clean rooms and HEPA filters, which most of us think of as, top tier, are powerless?
Well, the core argument, as you said, is that clean rooms protect wafers, not human beings. Their design prioritizes pressure differences and filtering bigger particles.
Things you might see, perhaps.
Right. But according to this source, that ignores the real physiological threat, the stuff you can't see.
Which is?
What they call the invisible threat. It's the ultrafine toxic particles, specifically PM 0.1 and smaller, tiny, tiny stuff.
PM 0.1, how small is that exactly?
We're talking about 1,000th the size of a human hair, really microscopic, and these often come alongside gaseous toxins, VOCs, volatile organic compounds.
Oh, VOCs, like formaldehyde, stuff from new furniture or paint.
Exactly. Formaldehyde, ammonia, chemicals from cleaning products, fragrances, plastics. The list goes on. Plus, they mention heavy metal vapors and microplastic dust, too.
Okay, so why are these PM 0.1 particles considered the biggest danger here?
It's about physics, really. Our bodies have natural defenses, right? Nose hairs, mucus. They catch the bigger stuff like PM10, even some PM 2.5.
Makes sense.
But PM 0.1 particles, they claim these just bypass all that. They're so small, once you breathe them in, they can apparently go straight through the lung lining, the alveolar capillary wall, and into your bloodstream.
Whoa, so they don't get filtered out, they get absorbed.
That's the argument. They accumulate inside your body, potentially impacting organ function over time. And VOCs are different again. That's like breathing a constant chemical soup indoors, forcing your body to metabolize these toxins continuously.
And standard filters, FPP, don't handle these well.
The source says they're virtually worthless against both these threats, which brings us to their big indictment of HEPA technology itself. The fatal limitation, as they put it, it's about the mesh filter. The holes in the mesh can't be too small.
Why not?
Because if they were small enough to catch everything, air wouldn't be able to get through, you'd have no airflow, no ventilation. The purifier would be useless.
Ah, right, the catch-22. You need airflow, but that airflow lets the smallest, potentially most dangerous stuff right through.
That's precisely their point. Countless ultrafine particles, PM 0.1 and below, just stream through the gaps in the mesh. But they also highlight another issue, a kind of mechanical failure.
Okay, what's that?
It's in a section they call deception revealed. They argue that these high-grade HEPA filters get clogged really fast, sometimes within days.
Clogged by what? The bigger stuff?
Yeah, the PM10 down to PM 2.5 particles. They build up and essentially create this non-breathable plastic film effect on the filter surface.
Okay, so the filter gets blocked. What happens then?
Well, air takes the easiest path, right? It's lazy. So when the main filter media is clogged, the air pressure forces the flow to find detours.
Like around the filter.
Exactly. Through tiny gaps in the casing, pore seals, any little leak around the filter itself. So air bypasses the filtration completely.
But the machine is still running, still blowing air out.
Right. So it looks like it's working, but you're breathing unfiltered air.
That explains something they mention. When a filter looks really clean, even after months or years, we usually think that's good.
But they say it's actually proof of failure. That initial layer of big particles sticks to the surface, maybe electrostatically, making it look dirty at first.
But then
the clogging happens internally, the air starts bypassing, and no more particles actually hit the filter face. So it stays looking relatively clean because Air isn't really going through it anymore.
Wow, so the visual cleanliness is misleading. It means the filter stopped working effectively ages ago.
That's the technical argument they're making. That relying on standard HEPA for genuine biological protection is, well, fundamentally flawed by its own design and limitations.
Okay, so if that's the problem they're outlining, this idea of indoor spaces as traps accumulating chemicals and bypass particles, then their solution is this Air 6-free maze purification system.
Right. They categorize it as air detoxification and harmlessness engineering. Quite a mouthful.
And the goal is achieving these 6 frees. What are they?
They promise a space that is simultaneously dust-free, germ-free, toxin-free, smoke-free, odor-free, and heavy metal-free. All 6.
That's comprehensive.
It is. They're talking about creating a completely different kind of indoor environment. Stable, chemically inert, a new species-level living space is the phrase they use.
The space where our bodies aren't constantly fighting off invisible threats from, like, the walls and furniture themselves.
Pretty much. Solving problems they say the human body just wasn't built to handle, like continuous low-level chemical exposure.
So to actually achieve these 6 conditions, the requirements must be pretty strict. It's not just plugging in a box, is it?
No. Definitely not. The source emphasizes that purification is a process, a gradual decrease in concentration over time, not an instant fix. And this leads to 3 absolutely critical operational requirements. Non-negotiable, according to them.
Okay, pillar number 1.
24/7 continuous operation has to run all the time.
Why?
Because those indoor pollutants we talked about, especially the gases from building materials, furniture, plastics, they're being released constantly, every second.
So if you turn it off?
Toxins just start building up again immediately. Running it for, say, 8 hours means the other 16 hours are spent recontaminating the space. It defeats the purpose of achieving that near-zero state.
Okay, constant operation. What's pillar 2?
This one's maybe even tougher. It must operate in an airtight space. Doors and windows shut, sealed.
Completely sealed. Why so strict?
Because if they're open, outdoor air comes in. And outdoor air, according to the source, is also full of toxins, PM 2.5 from traffic, pollen, industrial pollution, whatever. That influx instantly ruins the purification effort inside.
So the first rule is basically keep the bad air out.
Precisely. Do not let toxic air enter. That's the mantra.
But wait, if it's running 24/7 and the space is sealed, what about fresh air? Oxygen? You'd suffocate.
Exactly. That's the engineering challenge these first 2 pillars create. And it leads directly to pillar number 3, required fresh air integration.
Ah, so you do bring in outside air. How?
You need a dedicated fresh air system, but, and this is crucial, it continuously pulls in outdoor air, and that air must go through its own separate A6F purification process before it's allowed into the sealed room.
So you're purifying the outside air before it even gets inside.
Yes, you're essentially creating your own clean air supply from the external atmosphere first.
Okay, that makes sense. And what does that achieve inside the room?
This leads to a really important design feature. Indoor positive pressure.
Yeah.
Because you're constantly pumping purified fresh air in, the air pressure inside the room becomes slightly higher than the pressure outside.
And that does what?
It actively pushes air out. Any remaining stale air, residual odors, or tiny amounts of internally generated pollutants get forced out through natural leakage points, like tiny gaps in the building structure, or dedicated vents, maybe in the bathroom or kitchen.
Like an air barrier. It prevents unpurified outside air from just seeping in through cracks.
Exactly. It ensures the only way air enters is through the controlled, purified intake. It makes the airtight seal effective.
Okay, so that's the operational logic. But if the core problem they identified is the failure of mesh filtration for the smallest particles, this system's patent must rely on different physics, right?
Absolutely. It has to go beyond just catching things in a net.
So let's look inside this patented technology. U.S. patent number US 8268058B2. The multi-phase toxin elimination system. What's happening inside this maze? There are 5 phases.
Yes, 5 distinct stages. And the first couple are really about preparing the pollutants for removal. Phases 1 and 2 are the primary and secondary negative ionization zones.
Ionization, like in some older air purifiers.
Similar concept, but apparently applied differently here. This ionization does 2 key things, according to the source. First, it gives an electrical charge to all the particles floating in the air. Dust, germs, everything.
Makes them sticky, electrically speaking.
Sort of, yeah. Makes them much easier to capture later on. But second, and maybe more importantly for the gases and germs, the ionization process itself is claimed to perform molecular breakdown.
Breaking down the chemicals.
Yes, neutralizing viral aerosols directly and actually disassembling VOCs and other chemical toxins at a molecular level. They're being attacked chemically before they even hit a physical filter.
Okay, so ions zap the viruses and break down the gases while charging up the remaining particles. What's phase 3?
Phase 3 is the electrostatic adsorption layer. This is where those charged particles get trapped.
So it uses the charge to pull them out of the air.
That's the idea. It uses electrostatic forces to capture and permanently hold on to the remaining particles, viruses, bacteria. And a key claim here is no re-release. They argue that, unlike mesh filters that can shed particles, this electrostatic capture is permanent. It tackles that bypass issue, too, because capture depends on charge, not just fitting through a hole.
Right. But the really unique part, the name of the system, is phase 4, the maze effect. Air redirection with wall collisions. This sounds completely different. How does a maze catch particles too small for mesh?
This is where the physics of those ultra-fine particles becomes critical. Remember PM0.1? They're so small, they're subject to what's called Brownian motion.
Random movement.
Exactly. They bounce around chaotically because they're constantly being hit by air molecules. They don't just flow smoothly with the air current like larger dust particles might. They have inertia and this random energy.
Okay, so how does the maze use that?
The maze forces the air to make sharp turns. Complex paths, 90-degree bends, constant redirection. Because the ultrafine particles have this inertia and chaotic movement, they can't make those tight turns as easily as the air itself.
They keep going straight when the air turns.
Kind of. They slam into the inner walls of the maze instead of following the airflow perfectly. And when they hit the walls, they get stuck through microadhesion, maybe residual electrostatic effects. The source says every turn is a trap. It uses their own chaotic motion against them.
Huh. So it's not filtering in the traditional sense, it's more like controlled collision capture.
That's a good way to put it, exploiting the unique physics of the very smallest airborne threats.
And the result, phase 5, is the air coming out.
Is the final release of air where, they claim, toxins and particles are reduced to near zero levels, leading to those reported benefits like clear-headedness and breathing feeling gentle as a still ocean breeze, a noticeable biological difference.
Okay, now we need to address maybe the most provocative claim in this material. The inventor, the master, connects this tech not just to health, but to the entire semiconductor industry.
Yeah, this is where it gets really bold. The source flat out asserts that the world's most advanced semiconductor cleanrooms, the ones making the tiniest, most powerful chips, might have been illegally using this patented invention.
Illegally using it. That's a huge accusation. Does the source offer proof?
Let's be clear. They assert this based on their technical logic. They don't provide, say, internal documents from chip fabs, but their logic ties directly back to that PM0.1 problem we discussed.
How so?
Standard HEPA filters, as they've argued, let PM0.1 particles through. Now imagine trying to manufacture a complex microchip with features smaller than 12 nanometers.
Incredibly tiny.
Right. If even one of those PM0.1 particles lands on the silicon wafer during a critical step, it causes a short circuit. Boom, defect. You can't get usable yields.
So the physics demands a truly PM0.1 free environment for modern chip making.
That's the core of their argument. They suggest that the only way fabs could have achieved reliable production at sub-12 millimeter nodes is by using a technology that actually eliminates PM0.1, like perhaps their patented ionization adsorption maze system.
And they're implying this tech is the sort of secret sauce, the untold foundation behind the success of modern high-end chips.
That's the implication. They even suggest that if the industry seems stuck at certain nodes, like 12 millimeters in some areas, it might be because standard HEPA-based cleanroom tech has hit its fundamental limit there.
Wow, okay. So the argument is that what's needed to make reliable chips is exactly what's needed for human biological safety.
Right.
A truly PM0.1 free, toxin-free environment.
That's the link they draw. It's why they don't see this as just another air purifier product. They frame it as a survival solution against the modern environmental death trap, a way to create your own toxin-free microcosm.
So bringing this back to you, our listener, the contrast they're painting is really stark, isn't it? Old tech, clean rooms, designed for silicon industrial needs.
Versus this system, which the inventor claims is engineered specifically for the human body, or our biology, addressing threats standard filtration supposedly ignores.
And if you accept the premise, They lay out this idea that we're constantly inhaling and absorbing vast quantities of ultrafine toxic particles and gases, accumulating them until something breaks.
Then the need for something beyond just mesh filters doesn't feel like a luxury anymore, does it? It feels, well, critical. Urgent, even. The focus shifts from just reducing particles for comfort to aiming for near-zero concentration for actual health and survival.
It definitely reframes the whole idea of clean air. And that leads us to a final thought, based on their deception-revealed claim. The source argues that the very foundation of traditional air purification, HEPA, might hide this flaw filters looking clean because air stopped going through them long ago.
Right. The bypass problem.
So, if that technical flaw is widespread in the standard systems we rely on, maybe the provocative question for you is, what assumption about the air quality in your home, your office, the places you spend the most time, what assumption are you breathing in right now?
Definitely something to think about.
We'll leave you with that thought until our next deep dive.